Welcome, everybody. We still waiting for people to hop on, Ben, or?
Hold on one sec here. Right now we have 4 people on. So let's just maybe give it just
You
a
want to
second.
wait a minute or two?
Yeah, let's wait just a few minutes.
It looks like 1, and it looks like 3 AI bots.
Hey, I worked hard to get those in this. Just kidding.
The AI bots? Okay.
You got to boost the numbers, man. Just kidding.
I see 2 people.
Okay. We have quite a few registered. Let people pop in here.
Wait another minute or so. Maybe nobody wanted a part 2 of the commercial.
Oh no, they want it.
Well, let's go ahead and get started. I could do some introductions and then people will hop on. Thank you, everybody, for joining today. Appreciate your willingness to participate in our webinars. We have had a lot of traction on the webinars and people have been, seem like there's a lot of interest. Like I've said before, we by no means are experts working in the solar business, but we're trying to, I guess, jumpstart some discussions so that people can help each other in the industry. So today we are talking about commercial again. Our last webinar was commercial do's and don'ts, and we got the sense that there was a lot of things to cover from a commercial standpoint. And so we decided to have a part 2 of our commercial do's and don'ts. So on our call today, we have Catherine Kelso, who runs our commercial design department, Heath Harpster, who runs our structural department, and Greg Elvestad, who runs our electrical engineering department. Ben Peterson has always been a great resource, and he is director of our business development and sales and marketing. So thank you guys for hopping on. I'm probably going to just talk briefly about a couple things up front, and then we'll pass the time over to the group to go ahead and discuss some of the topic items. We kind of want this to be more of a discussion, roundhouse discussion, and I suspect that we'll try and get through our material pretty quick so that we can let you guys ask questions on your end, maybe even on some of the topics we covered before. I thought that it would be a good idea to talk a little bit about some funding sources. And so I did, and I don't know really much about funding sources, but I thought it'd be a good discussion topic and maybe helpful for some of you on this call. Probably have a lot more experience with incentives that are government incentives. But I did hone in a little bit on, I think it's our RAID is the funding source with the USDA. And I did send an email out to our local office here and did find someone who's a good resource who knows about that program. And from what I understand, Catherine, I think you had a little bit of knowledge on what the RAID program is about. I think you have to be in a specific area and it has to be a commercial project or agricultural project. So maybe Catherine, if you can just fill us in a little bit on what the RAID program is.
The RAPE program or the REAP program?
I'm sorry, the REAP program, REAP. Yeah.
Yeah, I don't know a huge amount about it, but it is government grant. It is agricultural and commercial, and there's some pretty large projects going in with it. So it's a few $1 million per grant that they're handing out.
Yeah, and I believe they give you a decent amount of. They actually do some blending as well too as part of that program, so you can get a better financing through the program if you qualify for it. And I'll drop into the chat while we move on to some other topics, the website that I have and the contact I have at the USDA to go through that. I know that there's a lot of other federal funds in place. Some have been in place for a while. We know that, I think everybody was waiting to see what would happen with the election, because I know that may affect some of where the available funding will be and how long we could see extensions of the funding, the federal funding. And that was for commercial and residential as well, too. So, maybe this would be a good opportunity if there's anybody who wants to interject some ideas on what they've had and what they've seen related to available resources, federal or state. That may be helpful. So, Ben, why don't we open up the floor right now to see if anybody has some input related to some of these available incentives for solar.
Yeah, if you want to raise your hand, I'll go ahead and unmute you so that you can drop your words of wisdom.
Well, if no one has any thoughts there, we can move on to the balance of our topics. I will drop into the chat the information I have from the USDA, and maybe that can be helpful for some of you working on these commercial projects. And then we could just move on to some other topics. By all means, raise your hand, even if we're in the middle of something else, if you can think of something related to funding sources, available funding sources, and we can always double back on that topic when we get to the question section. I think from a structural perspective, I think that's up first, right? Is that correct? And I think Heath is on that. So I'm going to turn the time over to Heath to talk about some aspects of structural as it relates to commercial. I know that there's been some changes with the ASCE requirements. Not all states are implementing them, but 722 is now a new requirement, moved on from 716, which in some senses is good, in some senses is bad. So I'm going to turn the time over to Heath. He's going to cover that.
Thanks, Scott, and thank everybody for joining. So ASC 722. It's really not implemented in many places yet. I know Florida has had it implemented all year. Some other states and jurisdictions are in a transition period where you have the option of using it currently, but you can still use an old code. For example, Virginia is in this transition period where they give you a year to be able to transition over, but you can still use the old codes. California will probably be adopting this sometime next year or in 2 years, I'd imagine. So just some things to get prepared for, because there will be some changes, like what's shown on the screen now, that they're going to introduce tornado loads, which will impact Central America and the eastern border, with an emphasis on Central. If you see that graphic there, that's kind of like, the centroid of where it's going to be affecting, pretty much Tornado Alley, where you would expect. So this would be affecting risk category 3 and 4 structures only. So that's going to be your important buildings such as hospitals, schools, government facilities, fire departments, police departments, stuff of that nature. So if you're not something that fits within that, then you don't have to worry about it. This is basically the same design procedure as we currently do for winds. It's normal wind design, but it can govern in those Central America areas. And that speed is actually based off the effective area of the building as a whole. So it's not really, from what I've saw so far researching into it, it's not effective based off of your PV area. It's going to be effective on that whole building. So the bigger the building, the bigger the load. And the last bullet point there, just to put more of an emphasis on that, it's going to be over that central area, like your Kansas, Oklahoma, stuff like that. So if you can move to the next slide, Catherine. Another big change is going to be on ballast systems, which is going to affect pretty much everybody. And if you look at these photos, you can see that there is no racking to most of these ballast systems. It's just trays, and then the panels connect all the ballast trays together. And I've looked at these kind of before and wondered, how does the force get distributed out? When you have mounts at, say, like this corner up here, and then you have another mount down here, what connects everything together to get those force into where you're actually mounted into the system with connections? And the only thing you have is the panels, and it looks like they're finally catching on to that and implementing that you need special testing to show that works. when talking to Iron Ridge and some other manufacturers, it doesn't sound like testing is really going to be the way to go. They're going to try to get some calculations put together to show that this works. I don't think anyone really has anything in place as of now. The only real way around it is to put mounts at every ballast tray, which I don't think anyone really wants to do. So to go through some of these bullet points, there's the code section. It says that solar panels shall not be considered as part of the load path that resists the interconnection force unless the panels have been evaluated or tested for such loading. So it only affects ballast systems that use panels to connect ballast trays together. I don't know if there's really systems that have integral racking in between all the trays. I think most of the systems are just connected with panels. So it's pretty much going to affect every ballast system. We've already gotten some rejections in California requesting this information, even though they haven't adopted the new code yet. And like I said previously, the really only way around these comments is to add attachments at every ballast tray. And that's what we've gotten with some of these conversations with AHJs and the comments we've gotten back. So if you want to go to the next slide, Catherine. Some other solutions around this. Like I said, to add attachments to every tray of the ballast system, which is not, the way we really want to go, I would imagine, for you guys as installers. Another way around is to not use a ballast system. If you need a tilt to the system, you can use tilt legs or standoffs to get the desired tilt. And then I know that sometimes a tilt and other factors are not what leads the design choice to use ballast. Sometimes you have build-up insulation on the roof or something that, so you can't make a connection to the roof. Sometimes that's what, leads that charge of using the ballast system. We have seen testing with these OMG fasteners that can penetrate thick insulation up to 16 inches, and they do have testing on that. So if you do have thick insulation on a system, on a roof, where I know they'll use tapered insulation and you can get up to 16 inches of insulation, they actually have testing with these screws so you can penetrate through that, and they have 2,000 pounds for a connection using 4 or 8 screws. So you can use something like that. And as far as engineers, we're okay using connections instead of putting all these weight on the roof. There's in the code, it only allows you to add another 10% lateral load to the roof without doing a full building lateral analysis, which can be quite cumbersome and could even be more expensive than getting the certification on the system itself. So we're more than happy to reduce the weight on these roofs. I know it's not the best from a installer's standpoint, because I know it's pretty easy to just go and add these to the roof, and a lot of people don't like penetrations. But just to keep that in mind, that adding less weight to roofs are always, it's usually always better for the structural engineering side of things. So I don't know if anybody had any questions about these code changes or what I've talked about before we move on to the electrical side. If anyone wants to raise their hand, or we can always just bring it up at the end as well.
Hey, Heath, I had a question that maybe might be a good topic here.
Sure.
If I know that the change in the ASC 722 is confirming load path, is that really only in areas where there's seismic, or you think that's going to be required in every jurisdiction that they're looking for load path?
So that note is under the seismic provisions for ballast systems. So I could see where that's probably going to be only in higher seismic areas. Now, those seismic provisions do affect ballast systems in non-seismic areas. Like, they have that mandatory seismic setback that I think still needs to be followed, even in areas where seismic is very unlikely, or an earthquake's really unlikely. So I don't know. It's really going to be dependent on the AHJ if they allow something to go through without that extra testing, or if they're going to try to push back. I don't think a lot of AHJs outside of California and other high seismic areas are really going to push back on it, though.
Yeah, I mean, we've only seen it really in one jurisdiction. It was in California, where seismic's kind of an issue, right?
Hmm.
Because but okay. There are some other ballast systems that I think come with frames on top of them where you just drop the panels in them, which may not be the issue, and then maybe moving towards using more of those than necessarily just the trays,
Yeah, I think moving forward, a lot of these or a lot of manufacturers are going to have another system that actually has some kind of integrated racking in between everything to combat this.
Yeah, and the panel manufacturers, again, they're kind of behind the eight ball. When they changed the ASC 716, nobody had testing on the increased wind speeds and loading. And so everybody was playing catch up. All these manufacturers of the panels were playing catch up, where they may start doing some testing to see if they could be utilized for frames and be able to have a load path going through them. I think that's going to happen over the next couple months before this really. But it wasn't until like March or April that they started doing testing back after ASC 716 was introduced or was in effect. So
yeah, they might just every panel manufacturer might have a specific panel they come out with that just has more of a rigid frame to it as well. That maybe just has like testing for this instance, But we'll see.
yeah, no.
Another item to go along with that real quick is the 3741 compliance, which is, for those that aren't familiar with this is the adjustment to rapid shutdown requirements for solar systems installed on buildings. Traditionally, it's been you need microelectronics installed at each module to shut everything off. There is a provision now for systems to have a system design without those electronics, saving a significant amount of money. And but there's some specifics related to the way that gets designed, and racking equipment has to be certified for that application. But just bear that in mind as well as another option. If you have any questions on that, we can certainly talk to you about that offline.
Thanks, Greg. That's it from the structural side. We kind of just wanted to go over these new provisions before they go into effect. So I think we're going to hand it off to Catherine for the electrical side.
Thank you. I'll handle some of the electrical, then Greg will handle some of it. One of the biggest things we're getting questions on with commercial is energy storage. So we decided we should probably be a good idea to talk about energy storage a little bit more. We touched on it very briefly in our previous commercial webinar. But sizing the energy storage is an important thing for solar. And even companies that are used to working with energy storage systems with residential, it's a little bit different for commercial. One of the things we see in commercial, and one of the big reasons why we use energy storage in commercial, is for what we call peak shaving. So there's an electric bill here on our slide, and we can see that you're getting charged on this electric bill. You're getting charged for kilowatt hours, which is what we typically see. And this happens on residential too. But what we're seeing on commercial that we don't see on residential is this down here. It's called a demand charge. So these demand charges are per kilowatt, not kilowatt hours. So that's how you can identify them. And you can see here on this bill that the demand charges are pretty hefty. They're $3,700 on this particular bill. And if you're sizing a battery system to deal with this, you have to look at the total amount of demand. So, and just to back up a minute to explain what the demand charge is at some point, this facility drew 131.5 kilowatts from the grid at one time for 15 minutes. And they could get charged for that amount for the next 3 months because they hit that demand. Some electric companies even have a worse penalty that if you hit a certain demand, you end up in a whole different rate code and all of your power bill is higher. So it's a big deal to be able to deal with this. And you have to look at it as kilowatts versus kilowatt hours. And when you're sizing the system, it's about the batteries, but it's also about the inverter. So an inverter can only give you so much power at one time. And if, for example, we went and got a Solarc 60 kW inverter and we're going to use it on this facility to offset demand, we're only going to be able to offset 60 kilowatts of this demand. We would need 131 kilowatt hours of power to be able to completely remove their demand charges. So if we only take off 60 kilowatts of this, they're still going to get charged for 71.5 kilowatts. And there's nothing wrong with that. If you're only offsetting half of the demand charge, you're still, in this case, you'd be offsetting close to $2,000, and it's still a worthwhile effort to do that. But you just have to know when you're quoting that that's all you're going to do. You aren't going to remove their demand charges with a single 60 kilowatt inverter. The other thing about demand charges when you're trying to reduce them is you need to know how long they sustained that demand. They only have to sustain that high demand for 15 minutes in order for the electric company to charge them, but they could have hit that demand 6 times in a day, or they could have hit that demand and sustained it for 2 or 3 hours. In that case, you have to make sure you have enough kilowatt hours stored in the battery to provide the 60 kilowatts of power for the sustained amount of time. So you really have to drill down into the minutia of the electric bill, where you're looking at, every 15-minute increment, what was their demand at those moments and how much time they spent pulling the high demand that they're getting billed for. It's very easy if they only hit that number once or twice during the billing cycle and only for 15 or 30 minutes, then you don't need a lot of kilowatt hours. You just need a big inverter. But if they're hitting that demand and sustaining that high demand for long periods of time, now not only do you have to worry about having a large inverter to cover it, you also need a lot of kilowatt hours stored in the battery to maintain that high power flow to offset the demand so that they aren't hitting it at any point in their billing cycles so that they don't get the demand charge. So that's what you have to look at when you're dealing with sizing the batteries for peak shaving. When you're sizing for backup power, we're all a little more familiar with that from having to deal with residential backup power or off-grid systems where you're adding up all the loads. And you still have to worry about how much power you have to power those loads if any of them are very large. But typically, we're looking at smaller loads like lights and computers and that sort of thing. And then it's just about how many hours those loads are going to be on and making sure you have enough kilowatt hours to cover those times. So that's what we're looking at when we're sizing energy storage for commercial. Other things with energy storage, and we're dealing with this on the residential side too, but it's becoming a problem on commercial because building departments are getting a little more strict about fire code. So the IFC is making everybody cringe when the building department starts asking about IFC code and how are they going to meet the IFC code. And a lot of times building departments don't even know the code that well themselves. So they'll just give you a general statement like, how are you going to meet the International Fire Code? And it's up to you to go through every detail in the fire code and all the things you need to do to meet it. So, and also too, keep in mind that the fire code applies to lithium battery systems that are over 20 kilowatt hours. So everyone thinks, oh, well, this battery system's real small. It's only 30 kilowatt hours, no big deal. Well, that's big enough to trigger International Fire Code jurisdiction, and you have to abide by all of the rules in there, even though they seem a bit excessive sometimes. So if you're putting the energy storage system inside, you're going to have to deal with having firewall separations from the part of the building that the battery is in versus occupied work centers. You have to have sprinkler systems in the buildings, and you have to make sure there's no combustible materials anywhere near the battery system. A lot of times we start looking at those and realize, okay, that's going to be a little bit constrictive and going to make this installation very difficult. So the solution to that is to put the batteries outside. Now all we have to do is worry about restricted access. Very simple to do. If it's a smaller battery cabinet, it can just be locked. If it's a larger system, then just have to have a fence around it. Very easy. We also have to make sure that if we're close to a parking lot where vehicles could hit it, we've got parking bollards. We still have to keep it away from combustible materials, which, it's easy not to set a gas can next to it, but you also have to look around at what, trees and dumpsters and things like that, where those might be, so that we don't have combustible materials too close to our battery system. So That is all I have on energy storage, so I'm going to hand it back over to Greg for talking about interconnection. You're muted, Greg.
Myself unmuted. Thanks again. I want to reiterate, thank you for attending. Appreciate your time. You have lots of places you can choose to be, but you're here with us. Thank you so much. Interconnection. Again, in this business, be it residential or commercial, interconnection is the toughest part of the project oftentimes, because you need to figure out, okay, we've got this beautiful system design. Where do we plug it in? How do we plug it in? And so it's just solar, so how difficult can it be? Well, some days it can be challenging. Some of the adjustments in the electrical code give us some options, but they're also adding some restrictions. So, for example, line side taps. Traditionally, you've had to install your overcurrent device within 10 feet of the point of interconnection. You've been allowed a little bit of leeway here to move up to what the slide says here, 71 feet from the point of interconnection, using current limiters. And basically, it's a fancy word for a fuse, if you will, constricting the amount of current in a fault condition such that it'll keep it from having a thermal runaway situation or exploding and causing a severe incident related to fire safety and so forth at a different location. Some of the folks on the call here have got experience using current limiters, and love to hear about that as we go further on in the afternoon here. Another option is making a load side tap on the bus, taking bus bars at 100%, which if you do residential, there's the single point of interconnection rating that matches the bus bar. Some circles, it's known as a Hawaiian tie-in, if you will, type of situation. Commercial-wise, it gets a little bit different because usually the PV interconnection is not the only device that's connected to the bus. So it makes it weird. What do you do? Well, you still have your 120% rule, which most jurisdictions will default to in a heartbeat. They will not even consider other options that are listed in the code. They just default to analyzing a plan set as per the 120% rule. And if it feels wonky or looks different, they'll reject it out of hand as being non-compliant. So what do we do then? Well, thankfully, the rulemaking officials that put together the code back when the 2014 was written offered up this beautiful under engineering supervision idea. And at the time, I wasn't present, so I can't say what all went on with the discussions, but the bottom line is they're taking the decision-making process for whether the service can handle the interconnection off the shoulders of the authorities having jurisdiction and placing those decisions on the shoulders of the electrical engineers that are doing the designs, folks like Catherine and myself. Now, what does this mean? Well, for example, you have an 800 amp bus bar. Your PV design puts you in a position where you can interconnect 150 amps of capacity. Well, under your traditional 120% rule, you can't do that. You've got, get the numbers. Take a 400 amp load center, 80 amps limitation there. 800, you could go 160 amps. So you'd say 200 amps of PV interconnection. So pardon the incorrection there. You've got 200 amps of capacity, but your bus can only take 160. What do? Do you derate? You can. And that's still a real thing that is an option for you to do that. But what if the switchgear is old enough that you can't find a breaker that you can derate down to? What do you do in that situation? Well, this is where under engineering supervision comes into play. And the code article is cited here. It's a little different for the 2023. It's B36, but the same thing is in play. you can interconnect a PV system under engineering supervision, provided that you evaluate the building load and perform a available fault current study on the service. And that's it. Very, very simple. Little bit of a fee involved to get those two documents put together, but the bottom line is it's a lot less expensive in most instances than trying to find something that may or may not exist or has got a 72-week lead time. I'm being facetious there a little bit, but not much, because lead times are getting ridiculous on a lot of things these days, and spending a little time for this under engineering supervision can be a way out. So what that does is it takes all of the other options that were there. Supply tap, load tap, bus ratings, some of breakers can't exceed 100%, all those things, it sets them aside and gives us the ability to say, no, I want to put 300 amps on an 800 amp switchgear because my client has that much usage that justifies an array that big. And without it, the system is not practical for them to proceed at 50% of design or some such thing that is limited under the earlier provisions in the code article section. Gives them the ability to put everything on the bus. And then that takes the responsibility for making that decision and places it on somebody like me. And we certify it, and then they can go ahead and proceed with that design. Especially, I'm going to circle back to supply chain things, especially in light of the fact that maybe a 2000 amp bus bar is not available, but a 15 or 1600 amp one is available, and it can be obtained in half the time. We engineer to those conditions, and you can get things ordered and delivered in a much more timely fashion and get your system installed and commissioned in order to start generating and give your client the benefits of having the system installed. So definitely something to consider. Couple of things on that. Arc fault studies, again, like I said, that's part of the under engineering supervision. Commercial projects and services larger than 200 amps in specific markets require an arc fault study all the time to make sure that the interrupting capabilities of the equipment installed is equal to or greater than the available energy at the point of the assumed fault location. The other thing that is becoming more and more predominant in circles across the country is our flash study. In most large construction complexes, large building manufacturing, that's been a thing for a long, long time. But related to solar PV, it is becoming more and more prevalent just due to this enormity of some of these projects that are being proposed. 2, 3, 4, 5, 10, 15, and even onwards up to 20 megawatts of generating capacity. There is enormous fault energy possible from the array being delivered to the grid at the point of interconnection. So when you're dealing with system design, you have that not only with the arc flash energy that the power company transformer can deliver on the secondary side of that transformer, you have a host of, just an enormous amount of energy that can be pumped into a short circuit at any given point along the interconnection path. It comes from both directions. And of course, when light is on, the modules are active and you have the continuous energy being pumped in. It needs to be protected from. So, and also when being worked on, the fault energy present forces a specific rating of personal protective equipment to prevent serious injury or worse in an operations perspective, operations and maintenance mode of servicing equipment. I mean, mechanical things fail. Stuff happens. Although you're monitoring quality for your terminations and all of your interconnection points, be they screws or MC4s or what have you, there is the potential for any point of connection between wiring and terminal blocks or wiring and inverters, what have you, for there to be a high resistance interconnection that can cause localized heating and create a fault situation or just a failed connector. When you're servicing that equipment, you need protective equipment that will reduce the exposure to a limit where you're unlikely or less likely to suffer injury. So that's another item to be concerned about. Arc flash studies they seem mysterious and kind of out there space-wise, but they're a real thing. You got to be careful to have the study and analysis done to protect the people that have to install and service the equipment you're installing. Is there a second slide there for me, or are we to the point of taking questions? I think we're there. Turn it back over to Scott and Ben and open up the floor to questions and so forth and invite comments. Thank you for your attention this afternoon.
Great. Well, thank you, team. Greg, Catherine, Heath, appreciate your expertise in the industry, and hopefully this has been helpful for all of you. At this point, why don't we open up the floor for questions, see if you guys have any additional information you can participate in the conversation or add to the discussion, or if you have some specific questions for anybody on our team. All right, just raise your hand if you have any questions.
And I did want to recognize Aaron from Iron Ridge that just jumped on the call. We appreciate them and their support.
Yes, welcome, Aaron. We actually had a call just the other day with Aaron and his team, just kind of, I know that they're working very diligently at the issues with the ASC 722 requirements, and we've been chatting with them as well. But yeah, he's been very helpful. Any other ideas or points that we need to make? Okay, well, we appreciate you guys hopping onto these webinars. We're hopeful that you guys find them helpful. And again, if you have any suggestions related to future topics, you could go ahead and leave that in the chat or email any of us directly on that. I did leave the USDA information in the chat, and there's a telephone number, and actually there is a spec sheet for that program, the REAP program, that is very helpful. You can just click on that link and be able to get to that point. And then you have Landon Mayer, who is a business program specialist who is here in the Utah office. I'm sure anybody can call him and he can give you information on it. On the website, there's specific areas that you can check your availability for the grant program based on the location. And hopefully that helps you guys, and hopefully you guys are aware of that. We'll probably try and give some other programs that are available as we move on to different topics as well. So, okay, if there's nothing else, we'll end our webinar. We appreciate all of your help, and all of our customers. We appreciate your support. And we hope that, it looks like Aaron had a question. Did you have a question, Aaron?
No, just a mistake. Sorry about that.
Okay, no worries. We hope you guys have a great week next week, being Thanksgiving. Enjoy the time that you're with your family, and we appreciate everybody's diligence in the industry, making this just a great industry to be in at this time. So thank you all.
Thank you.
Thanks, everybody.